Hi everybody, welcome to this video. This is Module 16 for Business, Math, and Calculators. And in this module, we're focusing on solving multiple step equations. In the previous video, we were looking at 1 and 2 step equations. So in this video, we're just going to step it up a notch and involve just more than 2 steps when solving the problems. The nice part is the rules don't change. We're still going to follow our 3 rules for solving equations, which is to 1, get the variable by itself, 2, do the opposite operation when working to get the x by itself, and then 3, doing the same thing to both sides. So those rules still apply. And then we follow order of operations in reverse as our procedure for how to get rid of the numbers and in our goal of getting the x by itself. So again, the steps don't change, the rules don't change, it's just that we have more steps to have to worry about in the process of solving for the variable. So with that, we're going to do a couple of example problems. So I will share my screen and we'll go ahead and get started with the problems. All right, so solving multi-step equations. So again, let's just jump into our first problem and go through the process. So in this problem, we want to figure out what x is equal to. We got a lot of stuff going on here. We've got parentheses, we've got variables in different terms, we've got different things that are being added and multiplied. We got all sorts of things going on. So this is definitely a good example of a multi-step equation. So our goal is to solve and figure out what x should equal to make the equation balanced. So just as a quick reminder, here are the steps that we follow as we work to get the x by itself. Again, if there's anything that doesn't apply in a step, we just skip over it and continue working our way down the list. So with that, let's go ahead and rewrite our problem. Now, the first step that we didn't have to do in the earlier videos is the whole simplifying process. We need to do that in this particular problem because we want to try and get the like terms combined, and if we can get rid of parentheses, that comes in really handy as well. So the 2 main things that we look to do when we are simplifying an expression in an equation like this is we look to do the distributive property if necessary, and we also look to combine like terms. So with that, the first thing I notice is we do have parentheses with a number out in front. So let's do the distributive property. Let's take that 3 that's outside of the parentheses and distribute it through the parentheses to make them go away. So when we do that, we end up with 3 times 2, which is 6x, and 3 times 1, which is the plus 3. So there's the distributive property. That plus 2x that comes afterwards is not in parentheses, so that just kind of tags along to the next step. Okay, so the first thing we've taken care of now is we have distributed to get rid of the parentheses. Now what we want to do is we want to try and combine any like terms that are showing up in our problem. And in this case, there are 2 terms that have plain x's in them, the 6x and the 2x. So those are like terms that we can combine together. So 6x plus 2x is 8x. The plus 3, again, just kind of tags along since it's just a plain number, doesn't have an x in it. We can't combine it with the 8x, so we leave them as 2 separate terms. And so now I end up with my equation looking like this, like shown on the screen. And now it should look kind of familiar. It looks like a 2-step equation, essentially. So all the simplifying work that we did is now making it so we can basically solve an easier equation. Okay. So with that, we're going to take 8x plus 3 equals 35, and we want to get rid of whatever's being added or subtracted first. So we're going to get rid of the plus 3 by subtracting 3. And again, we do the same thing to both sides of the equation. Anytime we do the opposite operation, make sure you keep the equation balanced. On the left, the plus 3 and the minus 3 cancel out to 0, leaving us with 8x. On the right, 35 minus 3 equals the 32. Now I'm down to a 1-step equation, so I got to get rid of multiplying by 8. We do the opposite operation, so we divide both sides by 8, and again, we do it on both sides to keep the equation balanced. On the left, 8 divided by 8 is 1. 1 times x is just our plain x, which is what we want to get to, a variable by itself. On the right, we have 32 divided by 8, which is 4. And there's our solution when all said and done. Now, if we go back to the original equation, we can always plug 4 in and see if it does in fact equal 35 on the left. If you go through the process and put the 4 into the parentheses, 2 times 4 is 8, plus 1 is 9, 9 times 3 is 27. The 2 times 4 is 8, so 27 plus 8 does equal 35. And so we are in good shape. We found the correct final answer. With that, let's do one more example problem that involves multiple steps. This time in our equation, notice what makes this one a little bit different than the previous example is we have variables kind of all over the place. There's variables on the left and there's variables on the right. So we're going to have to work to get all of the variables kind of grouped together into the same term. So here's our reminder of the steps that we go through. Let's go ahead and start. The first thing I wanted to try and do is you want to try and simplify as much as possible. So let's focus on the left-hand side to get started. We have some like terms. We have the plain x and the 8x. So that's going to get us 9x minus 5. Okay. On the right, we have some distributing to do. So when we distribute the 3 through, that gets us the 3x plus 6, and then that plus 7, so it's not in parentheses, just kind of tags along. We got a little bit more simplifying to do on the right-hand side as well. We have the plain numbers, the 6 and the 7, so we can combine those together. So now I'm down to this equation, 9x minus 5 equals 3x plus 13. So we've got everything as simplified on both sides as much as possible. Now, here's the new thing that we haven't seen in an equation before in any of our videos, and that is we have a variable on the left and a variable on the right. So we have to get them grouped together on the same side of the equal sign. Now, to do that, we have to make the term go away on one side of the equation. So, for example, if we get rid of the 3x, that's positive 3x or plus 3x. So to make it go away, we're going to have to subtract it. We're going to subtract 3x. And we're going to do that to both sides of the equation because we're making it go away on one side. We have to keep the equation balanced and do the same thing on the other side. So on the right, what we end up with when we put the like terms together is 9x minus 3x, which is 6x, and then the minus 5 tags along. On the right-hand side, the plus 3x and the minus 3x cancel each other out. They end up equaling 0, and 0 plus 13 is just 13. And now I'm down to a two-step equation like we solved in the previous video. And so now I can continue on getting the x by itself and working towards finding the solution. So what I need to do next is get rid of the adding and subtracting piece. So I'm going to get rid of minus 5 by adding 5, and I'm going to do the same thing to both sides of the equation. On the right, the minus 5 and on the left, the minus 5 and the plus 5 cancel each other out, leaving us with 6x. On the right, 13 plus 5 is 18. Finally, I gotta get rid of multiplying by 6, so I'm going to divide both sides by 6. On the left, the 6's cancel out to 1, leaving us with just 1x or plain x. On the right, 18 divided by 6 is 3. So there's our solution, x equals 3. Again, you can always check your work by plugging the number back into the original equation and seeing if things balance out. In this situation, I have to plug 3 in on both sides of the equation so I can get to see if they equal. On the left-hand side, when I plug them in, 8 times 3 is 24. 24 plus 3 is 27, minus 5 is 22. So I get 22 on the left. On the right-hand side, 3 plus 2 is 5. 5 times 3 is 15. 15 plus 7 is also 22. So that quick check shows us that our final answer is, in fact, correct. And there you go. There's our solution. So there you go. There's a couple of examples. The two examples that we went through are probably the most complicated types of equations that you're going to see, especially in this class in business math. They won't get too much more complicated than that. So if you can solve the two problems that we just went through, you're in really good shape for solving the equations, for particular for what we need to do in this class. Like always, please let me know if you have any questions on things. I'm happy to help you out, help make sure that you're good to go on solving equations. So let me know what I can do. Otherwise, good luck as you work towards solving equations and working on the homework and getting ready for the quiz. If you do have any questions, please let me know. I'll be happy to help you out. Have a good rest of your day. Thanks for watching.